Following decades of unheralded passage through the outermost extremes of the solar system and into interstellar space, Voyager 1 has once again amazed the scientific world with a finding that shatters our most fundamental assumptions about the universe. This discovery, however, is not made on some foreign world or moon, but at the very boundary of interstellar space itself. About 15 billion miles from home, in the dark, cold vastness where the sun's influence gives way to the huge galactic sea, Voyager 1 has reached a stormy, turbulent zone where interstellar plasma acts in manners never seen by present scientific theory. This remarkable discovery, arising from a 1977 launched spacecraft fueled by a tiny, dwindling reservoir of plutonium, forces researchers to reevaluate decades-long assumptions regarding the character of deep space, the organization of our galactic backyard, and the very limits that circumscribe our solar system. Well past its shelf life, Voyager 1 has shown that even in its own senescence, it is still capable of changing the trajectory of space science. For nearly 4 decades, Voyager 1 has wandered through the outer reaches of the solar system. In 2012, it reached the point of officially transitioning to what scientists define as interstellar space, past the heliopause, theoretical boundary where the solar wind is opposed by the interstellar medium. For years, this zone was considered a relatively placid transition area. But new information paints a different picture. Rather than a tidy transition from solar to galactic realms, Voyager 1 has measured a chaotic boundary, a foaming edge where the outermost fringes of the solar wind are striking head-on with the energies of the galaxy. What Voyager 1 has revealed is a sheath-like, shock-filled zone immediately outside the heliopause, where charged particles collide brutally and magnetic fields spiral irrationally. The plasma wave subsystem on the spacecraft, with its 1970s technology, is surprisingly still operational and proved crucial in the detection of high-frequency oscillations and severe electron density fluctuations. These are far from trivial figures. They indicate an energetic environment filled with dynamic activity, where cosmic weather, similar to terrestrial storms, lashes the emptiness in great waves. Scientists had long speculated that interstellar space outside the heliopause would be uniformly homogeneous, a silent, smooth sea. Voyager 1, however, has discovered something more akin to a galactic maelstrom. Interstellar plasma here rages with uncooperative energy, magnetism flares unannounced, and dense electron clouds rush like storms across the boundary. It's a find that has utterly transformed theories of the interstellar medium and hinted that our own galaxy is much more vigorous than we had realized. Perhaps the most shocking feature of this new region is its diversity. Measurements of plasma densities reveal rhythmic pulsations that baffle explanation in terms of any solar phenomenon. These oscillations suggest a source well beyond the Sun, possibly the impact of remote supernova remnants, intergalactic magnetic organization, or even gravitational tides from the nearest stars. Other scientists now think that interstellar space, long conceived of as a lifeless vacuum, teems with galactic weather patterns sculpted by enormous, energetic processes occurring far across the Milky Way. Such interstellar storms might be created by shock waves of exploding stars, quasar jets, or giant objects such as black holes distorting spacetime itself. These energies might create waves in the interstellar medium which only now, thanks to Voyager 1, are humans starting to receive. Essentially, Voyager 1 is listening to the far-off thunder of galactic processes that have been sculpting the universe in silence for centuries. This discovery also reframes our understanding of the function of the heliosphere, the shielded bubble formed by the solar wind that contains the planets. Previously considered quite stable, the heliosphere is now more vulnerable than initially thought. If the heliopause boundary is fluctuating and interacting with turbulent forces beyond, then the shield protecting Earth and the other planets from high-energy galactic radiation may be more porous and dynamic than imagined. This has profound implications for planetary climate, radiation levels, and perhaps even biological evolution. Over geological time, periods of high galactic radiation, caused by heliospheric compression or plasma storms, could subtly affect DNA mutation rates or influence atmospheric chemistry. Although speculative, it is conceivable that interstellar weather contributed to evolutionary history on our planet, and possibly will continue to do so in the future. The sun's shielding function, and its interaction with the galaxy, is no longer a mere abstract problem in astrophysics. Perhaps it is intimately linked with the fortunes of life on Earth and elsewhere. In that context, Voyager 1's travel is no longer just a scientific endeavor, it is an investigation of the conditions of life in the universe. Its results contradict how we measure habitability. The Drake equation, which is famous for its attempt to quantify the number of communicating civilizations in the galaxy, doesn't take into consideration changes in interstellar turbulence or plasma weather yet. But if large areas of the galaxy are more or less habitable depending on how dark they are due to interstellar storms, then galactic geography becomes a new and significant variable. Other star systems, located in peaceful pockets of space, may experience extended periods of serene radiation protection, while others may endure a millennia-long beating from high-energy particles. These variables would have the potential to significantly skew the likelihood of life persevering, developing, or even existing at all. It implies that life conditions are not just a function of distance from a star, but distance from chaos, cosmic chaos. At the same time, Voyager 1's viewpoint, its literal location in space, makes its measurements invaluable. It is the sole object that has ever been constructed by humans that has entered interstellar space. Telescopes such as Hubble or the James Webb Space Telescope provide breathtaking vistas across space and time, but they peer from outside. Voyager 1 is not so. It is immersed in the surroundings, enfolded by the forces it measures. It's the distinction between seeing a storm in a satellite image and being in its midst. Its measurements provide scientists with a hands-on feel for interstellar conditions, the texture of the galactic wind, the feel of magnetic fields, the pressure of charged particles colliding with each other. Its signals are weak, taking almost a day to reach Earth, but rich with information. Each transmission from Voyager 1 is a whisper from the fringes of the known universe. Each one peels back yet another layer of the galactic onion. And with each new discovery, scientists are being compelled to update their models of the universe. The interstellar medium is not static, it is shaped by motion, energy, and perhaps even by unseen cosmic players we have not yet discovered. The idea that our solar system's edge is a tidy line has to be put out to pasture. Voyager 1 is teaching us that space is untidy. Edges are fuzzy. Forces intersect in chaotic manners. The heliopause might not be the end point. There could be layers, zones of compression, magnetic reconnection, or even enormous pressure fronts enveloping space. These unseen storms could sweep the galaxy like ocean currents, carrying energy and particles over thousands of light years. In addition, the evidence indicates that this turbulent zone may be the last gasp of the solar system as it merges into the wider galactic landscape. Just as the banks of a river flow into the ocean, the solar wind doesn't cease to exist suddenly, it disperses, engages, and gradually disappears into a greater entity. But in doing so, it could form structures, energy gradients, and magnetic shells that extend much farther than we would have thought. The very processes of star death and renewal may be acted out in these edge areas. The chaotic mixing at the heliopause might reflect the galactic recycling that takes place as stars shed their matter and help form nascent systems. Voyager 1 could be seeing a miniature of the cosmic cycle, a shift not merely from solar to galactic control, but from one state of cosmic matter to another. As Voyager 1 goes farther, it could encounter even stranger things, more intense plasma disruptions, shifts in particle types, or completely unimagined types of energy. Researchers are already planning to update their models accordingly. Next-generation interstellar missions, such as the planned interstellar probe, are in development with Voyager's results in mind. Those missions will require more advanced radiation shielding, improved detectors for observing plasma behavior, and more extended lifetimes. Voyager 1, in this way, is the pioneer for a new era of exploration. The cultural importance of this cannot be exaggerated. Voyager 1, a human-made device prior to the existence of the Internet, of smartphones, of the fall of the Berlin Wall, is now the farthest ambassador of humankind. And even today, it keeps on educating us, to humble us. Its messages keep reminding us that the universe is not a completed book. It is an ongoing tale, and we are still on the first pages or two. In a very important sense, Voyager 1's most important accomplishment is not technological, but existential. It has changed the way we think of our place in the universe. It informs us that even the darkest, most frigid parts of space are not empty and inactive. They are alive, vibrant, reactive. And out there, Voyager 1 keeps on listening, feeling, reporting. Its silence is eloquent. Its signals bear the spirit of exploration. If you've reached this point, thank you for coming along with us on this ride to the shores of the unknown. If you've enjoyed this video, would you mind liking it and subscribing to our channel for more tales from the frontiers of science? And let us have your opinion in the comments below. What do you think Voyager 1 will encounter next as it cruises into the depths? One thing we know for sure, the universe remains full of secrets. And we are one step closer to unveiling them, thanks to Voyager 1.